Today, guys, we are on to lesson 11, partial products and the standard algorithm. Okay, the standard algorithm is also known as the shortcut method. Okay, so you'll hear me call it the shortcut method probably more than the standard algorithm. All right, we are going to compare multiplication algorithms today. Okay, it's not your turn to talk. That's the problem. Okay, 52. All right, we're going to start by finding the value of each of these expressions mentally, and we'll share in about 1 minute. So page 52. All right, let's share. What is 5 times 100? 1. We'll start there. All right, Quinn.
505.
505. Yep. And what is 5 times 102? Aubriella. 510. What is 5 times 203? Brooks.
1015.
1015 is correct. And 5 times 404. Okay, Bella.
2020.
Yeah, I agree. Okay. Now, what relationships do you see between these expressions? Vivian.
That one relationship is that 5 times. So the last expression and the first expression they both double the same number.
101 doubled is not 404, but I like your thinking. You're on the right track. Jerica.
5 times 101. The 505 is
Oh, palindrome, where it's the same number forward as backwards. What a good observation. Quinn.
So I see that the ones and the tens go up by 5.
So if we look at the ones, we have 5, 0, 5, 0. Is that what you're looking at? Oh, 5, 10, 15, 20. Very good. I like that. Okay, Kate, what'd you notice?
That they're all being multiplied by 5.
They're all being multiplied by 5. We can see one of the factors is definitely 5. Gage?
It's either going up by 1 every time or 101 every time.
Oh, okay, when we look at this factor over here. Okay, so it's kind of counting by 1 or 101, which is very interesting. Delaney? Yeah.
And then 5 times 3 is 10, and then 10 times 2 is 20.
So that helped you to figure out kind of the second part of that answer of the product. Okay, Keston.
And the ones place for the hundreds is going up by 1 every time.
1.
5.
Yeah, 1, 2, 3, 4, which is adding a group of
5.
5 every time. Okay, Coral.
It helped me just because the first 3, I just doubled the number.
You just doubled the number?
Yeah.
Okay. Jace.
If you get so if you get the first 2, if you add those 2 together, you get the third one, and then if you add those 3 together, you get the third one.
Oh, so if you could figure out these 2, it helped you to figure out this one, right?
Mm-hmm. And then if you figure out those 3, it helps you figure out the last one.
So they were all what I call helper problems, weren't they?
Mm-hmm.
Okay, last one, Madeline.
The 101 helped me figure out the 102 because all you have to do is just add 5.
So it's just adding one group of 5, isn't it? Okay. All right, you guys. So mark your spot with your pencil and let's look at our launch. What'd I forget?
This is our thing.
This is our thing. Oh, there's no launch. Hold on.
Yay!
This is the second time they've done it. I'm going to make it the launch. Close your books. I just want to make you close your books. Aren't I nice? All right.
Yes.
So, look at me, guys. Couple things for today's lesson. I know you guys are going to want to kill me, but we are all doing the synthesis for at least the first activity.
Okay.
No working ahead today.
What?
No.
So here is what we are doing. I don't even know how to explain to you guys how important it is to see that connection between the standard algorithm or the shortcut method and partial products. It is so important that I'm making you all stay on track and no working ahead like we've been doing, okay? Not today. Maybe for activity 2, but not for activity 1. Activity 1, you are working with your math partner. You're going to look at Kieran's method and you're going to look at Diego's method. Then you're going to answer these 2 questions, which we're going to need to synthesize later. Then for question 2, it says find the value of each product. Here's my challenge for number 2, and this is where we were struggling yesterday. It says find the value. Does it say use the box diagram?
No.
Does it say use the shortcut method?
Yes.
Does it say use the partial products?
No.
It doesn't say. But here's where you guys are struggling. You need to do the method where you get the right answer. So just because your best buddy is doing the shortcut doesn't mean the shortcut is the best choice for you. You have to be honest with yourself and you need to do the method where you are getting the right answer. If you want to go for a 4, should you do more than one method?
Yes.
Yeah.
Absolutely. Then you can check. Okay? If you get a different answer than your partner, what do you do?
Check.
Okay, that's easy to say, but what does that mean? What does it mean to check? Aubriella.
I guess compare your answers.
You could compare your answers, but if you don't agree, how do you decide who is right? Hadley.
You could do division.
And you guys know that. You could do the opposite operation, but I'm thinking of an even better idea. Emma, do you know what I'm thinking? Do a method neither one of you did, right? Or you do a different method. You know, if you did the box method, maybe you do the shortcut method and see if you get the same answer. But we have 3 methods that we have learned, 3 strategies so far. If your answer is not the same as your partner's, you both need to solve it again using a different method. Okay?
What if
Right in.
you and your partner, can you and your partner do different, do different strategies?
I think that would be really interesting if you did. So, like, if Braden did the box method and Riker did the shortcut method, what would really be interesting is if they both got different answers and then did the other method, right? Okay. Here's what I want. I think you only have those 2 questions. When you are done, I do not want you chasing me around the room today. When you are done, you and your partner are going to come back to your floor spot. Because remember I said we are all synthesizing together today. Okay? You're going to synthesize. Okay. Somebody turn on the lights and let's head to your seat about 10-ish minutes. So guys, we're going to synthesize. So, you need your book open so you can look at your work. But I also need your eyes up here. Okay, the first thing I really want to look at is we have Kieran and we have Diego, right?
Yeah.
Now, let's pretend for a moment that you don't know the shortcut method, okay? How did Kieran get this answer? 2,139. How do you do it, Gage?
So she did 3 times 3 equals 9. And then 3 times, wait, 1 second. And then 3 times 1 equals 3. And then 3 times 7 equals 21.
Okay, yeah, she sure did. How else could you explain that? Brooks?
So he like squished it basically.
Yeah, and we don't know if Kieran is a he or a she, but they squished. Did you see they kind of squished the partial products? Because if I was to add all 3 partial products, I would get this answer. But I thought that was cool how you explained it, Brooks, how you said, oh, well, it's just squished. Riker, what'd you say?
Kieran could count 713 3 times.
So literally, Kieran counted 713 3 times, right? Okay, last one, Erin.
What she did is she multiplied all the numbers of 720 and 713 times 3, and put all the numbers on the bottom.
Okay, guys, I think this is such a good example of why the shortcut method is called a shortcut. You have to write less. Okay, you're also thinking less, okay? You're thinking about the order of what you're doing. Whereas when you're doing partial products, you're thinking about numbers and place value, okay? That's why I think it's so important that you guys see that connection. All right, so our actual synthesis, we're going to share and explain some calculations. So if I have 212 times 4, let's hear an answer and then tell me how you got it. All right, Cade.
848, and I did the standard algorithm and partial products.
So you did both?
Yeah.
And did you get the same answer for both?
Yep.
Awesome. Bella, what did you do?
I got 848, and I did the box method, but I split up the 4 into 2.
So I thought that was interesting because it's 212 times 4. So Bella's group thought, hey, it's easier to multiply by 2 probably, right? And they split the 4 into 2 and 2. And then they had 210, 2, right? And so they did it like that. So you had more numbers to add up, but maybe you can multiply by 2 faster, so it might have worked better. Okay, Keston, what'd you guys do?
I did the standard algorithm and the box method, and I got 848.
And you got the same answer. Okay, let's look at the second one. It was 4,132 times 3. And what did you guys get for your answer? Gage, what'd you get?
12,336.
And how did you get that?
I did the standard algorithm and box method.
And did you get the same answer for both? Perfect. Jace.
I got 12,396, and I did the standard algorithm and the shoe method. Oh, wait, Miss Macro, you put 3 instead of 9.
Oh, did you say 9?
Yeah.
Okay,
Yeah.
I was just going to say, okay.
You said 3.
Okay.
I think he said 12, actually.
So you did, okay, I was like, we've got 2 different answers. We were going to have a debate. Kara.
I did the box method and got 12,396.
Good. One more. Emma.
I got it wrong because I did 4,132 times 4 and 3.
Emma, we've talked about this. So you got to copy the question right? So pay close attention to what you're doing, guys. Okay, Awesome. I love that you guys were all doing different strategies and you were using them to check. So, in our next activity, we're going to take a closer look at the standard algorithm. Mark your spot in your book with your pencil, and we're going to look up here. Okay, now Kieran and Diego are multiplying 4 times 223. Okay? So you're going to look at them and you're going to talk about how they're alike and how they are different. And guys, question B, I think we're going to be discussing. Where is the 12 in Kieran's algorithm? Don't answer it.
I know, but I think we answered that same question in the first part.
Yeah, the exact
same.
Yeah. And it's just literally just a different problem.
It's a different, I know.
Can we skip it?
I know, but it is different. So no, we're not skipping it. Listen, don't talk over me, okay? Guys, listen. This is actually very important, okay? We're going to be talking about where the 12 is. There is something a little different here. If I tell you, I'm going to give away the whole thing. Number 2, you're going to try using Kieran's algorithm. So you're going to do the shortcut method, which we probably should know how. But look at B. Check your work using a different method. So is it a choice to check with a second method?
No.
No, you need to. Okay, then we're going to synthesize. Okay, same as before. 10 minutes, work with your partner, then come back to the carpet. Okay, so guys, first of all, we're going to talk about question A. How are Kieran and Diego's algorithms alike? Now, if you said they both multiplied the same number and they both found the same answer, I'm going to tell you you're not done. That's not correct. Well, I mean, they did do that, but what in their method is the same? Hadley.
They both lined up their digits.
Did you guys notice that? This looks very different than the box diagram, right? So they did. They lined up their digits. What else was the same? Gage.
They're like because Kieran's is just a shorter method than Diego's.
That sounds like a difference. How are they the same?
They are alike because Kieran's is just a shorter method than Diego's.
That's a difference. Cade.
I will. They're like because they both go digit by digit.
They both go digit by digit. So that is a similarity in their methods. So Diego did do 4 times 3, but he stacked his products. Over here, Kieran did 4 times 3, but he didn't stack his products, did he? Braden.
I said Kieran's is just the shorter versions of Diego's.
Now let's talk differences. That would be a difference. He wrote less, right? That's a difference. He wrote less, right? How else are they different? Yeah, Brooks.
So Diego doesn't carry a 1. He just writes the number down, but Kieran does carry the 1.
You guys, did you just hear what he said?
Yes.
That is a very important difference that only like 5 of you wrote down. Okay, literally. Do you guys see the blue one right here?
Yeah.
Diego did not do that. Diego did not carry a 1. So that's a difference. Okay? Here's what I want to know. Question B. Where is the 12 in Kieran's diagram? I see the 12 right here in Diego's, but I do not see it in Kieran's. Vivian and Madeline, pay attention. Riker, where's the 12?
The blue one is the 10 and the 2 in the answer and the 1 that's right.
Okay, will you get 2 tickets out of there for 2 reasons? Reason number 1, put your hands down. He said Kieran carried a 10. Literally, it's the number 1, but if we truly understand the shortcut method, he didn't carry 1, he carried 10. Okay? Remember, this is the number 12. The number 12 is made up of a tens place and a ones place. It's chicken scratch is kind of what I call it. It's a shortcut method because he put a 1 to hold the place of 10. That's why it's a shortcut. Okay? Here in Diego's method, I've circled it like 1,000 times. He wrote the number 12. He doesn't have any shortcut chicken scratch. Okay? Kieran understands it, I hope, but he carried 10. Okay? And he wrote down the 2, which is your ones place. The shortcut method is all about place value. And if you don't have those digits lined up, you don't get the right answer. Diego's method, it's really nice if you line up your digits, but you can still get the right answer if they're not lined up. Isn't that interesting? Okay, now we're going to look at the actual synthesis. Today, we compared the standard algorithm for multiplication to an algorithm that uses partial products. Let's see how we would find 3 times 512. That was part 2, right? Okay. Raise your hand. Tell me your answer and tell me how you found it. Sit down, Jace. We're not going anywhere yet. Gage, what'd you get?
1,536.
And how did you get it?
I did 3 times 2 equals 6, 3 times 1 equals 3, 3 times 5 equals 15.
Was there any tens to carry in this case? No, there wasn't. So the standard algorithm, pretty quick and easy. But let's hear some other ways. How did you do it, Coral?
I did the block method.
Okay.
First I split the number 512 in half, and I did 3 times 500, is 1,500.
Okay.
And then I did 3 times 10, which is 30. And then I did 3 times 2, which is 6. And then I just added all of those together, and I got 1,536.
Okay, that's another way. How'd you do it, Michael?
Well, because I did it like so. There was no ones carrying, but I did 3 times 2 equals 6. So I just put it. I didn't make it long. I just made it.
So you just did the shortcut method? Okay. Did anybody do the stacking?
Yeah.
You checked it with that?
I did it.
Okay, you did it that way? You did that way?
I did. I checked it.
Okay. Before I send you to do your cool down. This is your cool down. Okay. All right. Questions, Jace?
I call Diego's method the shoe method because it looks like a shoe.
It does. I can see the shoe in there. Yeah, it kind of looks like a shoe.
Yeah.
It will forever be known as the shoe method. Okay. Oh, guys, we're losing it. Sit down. We have one more question. Hadley.
If you wanted to get a 4 on the cool down, could
Yes.
you do a method?
Yes. Now, here's the thing, you guys. We have 10 more minutes until cleanup. So what I would do is I would solve each of them one way, and then I would see how much time you have, and then solve the second way. Here is what they want you doing when you're done. When you are done, turn it in, and they want you doing the centers. Okay?